Example 1 here on the mean and standard deviation is taking a look at just simply finding the mean and standard deviation. So we've been given a list of numbers here, so we can see the numbers presented on the screen now, and we're asked to find the mean and standard deviation of these numbers. So first let's start by calculating the mean here. So for the mean here, all we simply need to do is take the sum of these numbers here and divide it by the total amount of numbers. In this case here we've got 8 numbers, so all we need to do is add all these values together and divide the sum by 8. So in that case here, the mean is simply going to be 6 plus 10 plus 4 plus 7 plus 24 plus 13 plus 9 and finally plus 15 here. Okay, and all we do is we take this value here and we divide it by the total amount of numbers, which in this case is 8 numbers. Okay, and here we just need to evaluate this on our calculator here, and if you do this correctly, what you should obtain for the mean here is 11. Okay, so the mean is simply 11. Now for the standard deviation, there's a little bit more work involved here. What we need to calculate first is the mean of squares. So the mean of squares. So to calculate the mean of squares here, we need to repeat a very similar process as to what we did here. However, this time we're going to square each value. So the mean of squares here is going to be 6 squared plus 10 squared plus 4 squared, and again we just repeat that for all these numbers here. Okay, so we write all these out in full here. Plus 13 squared plus 9 squared, finally plus 15 squared. Okay, and again all we do here is we divide this by the total amount of numbers, which again is 8. Okay, so we divide that by 8, and if we sum these numbers up here, make sure that we square each value and divide that by 8, what we get here is 156.5 there. Okay, what we also need here is the square of mean. So the square of mean here is simply going to be our mean value squared. So the square of mean, simply our mean value squared. So that's 11 squared, giving us 121 there. So why have we gone on to calculate the mean of the squares and the square of the mean here? Well, the reason we've done that is because the variance is calculated. So the variance is calculated using the mean of squares here, this value 156.5 minus the square of the mean here. Okay, so the variance is going to simply be 156.5 minus this value here for the square of the mean, 121. And if we do this on our calculator here, what we get is 35.5. But we don't want the variance, we want the standard deviation. And remember, the standard deviation is given as the square root of the variance. So therefore, what we require here is a standard deviation. The standard deviation here, and that's given as the square root of the variance, which is 35.5. And in that case here, what we get is 5.96 there. Okay, so that's our value for the standard deviation, and that's our value for the mean there. And that gives us the solution to example 1. Example 2 here on mean and standard deviation is taking a look at finding the standard deviation from a grouped frequency table. So here we're told the number of cars sold by 100 small used car dealerships was monitored over the course of a day. The results have been collated into a table, and we're asked to find the mean and standard deviation of the number of cars sold. So what we've got here is our data in this table. So we've got the number of cars sold and the frequency here. Now the first thing we need to do here to find the mean and standard deviation from a grouped frequency table is to set up a new table. So for our new table here, what we need is 2 extra columns. We need fx, which is going to be the frequency f times by the number of cars sold, which we denote as x, and we also need fx squared. So that's going to be the frequency times by the number of cars sold squared. So we'd square each value here and times by the frequency. And if we do that correctly, what we should get is something that looks like this. So if we get rid of our table here and set up our new table, we get something that looks like this here. Okay, so fx, that's going to be 0 times 1, giving you 0. Same for fx squared here, 0 squared times 1, also gives you 0. If we check that then for 2 and 7 here, well, x times f, fx, would give us 2 times 7, 14, and then 2 squared is 4, times by 7 gives us 28. So that's how we obtain this table here. And notice we've got our totals here at the bottom, 100 for the frequency, for the sum of fx, that's 446, and for the sum of fx squared, we get 2,330. So now to find the mean then, so for the mean here, we just simply use the formula that we know and we're familiar with. So that's going to be equal to sigma fx, so the sum of fx divided by sigma f. Okay, so the sum of the frequencies. And in that case, sigma fx, well, that's the sum of fx, which we've got here at the bottom. That's our total. So that's 446 for the numerator. And for the denominator then, that's the sum of the frequencies, which we know is 100. So in that case, we do 446 divided by 100, and that gives us 4.46. So we know the mean is equal to 4.46. What about the variance then? Well, for the variance, we need to use, again, a formula that we're familiar with. And for the variance here, we do this as sigma fx squared over sigma f, and then we minus the mean squared. So the mean here we've just previously found, that was x bar, that's 4.46. So we're going to minus x bar squared. Okay, so it's going to be minus 4.46 squared. For sigma fx squared, well, that's just the sum of this fx squared column, which we know is 2,330. So we do 2,330. We divide it by sigma f, which is, again, it's just the sum of the frequencies, so that's 100. And then finally, we just minus x bar squared, where x bar is the mean here, which we found as 4.46. So minus 4.46 squared. And if we evaluate this, this gives us 3.4084 there. So 3.4084. That's our variance. But remember, and just be slightly careful here, we're looking for the standard deviation for this question. And just remember the relationship then between the standard deviation and the variance. If we've got the variance, we just need to take the square root to get the standard deviation. So we're going to take the square root of the variance. So the standard deviation then, so for the standard deviation, this is just equal to the square root of the variance, so the square root of 3.4084. And if we evaluate this on our calculator and give this solution to 3 decimal places, that would give us 1.846 there. Okay, and that gives us our standard deviation and our mean there. So that gives the solution to example 2 there on mean and standard deviation.